We're surrounded by these substances that are kind of living a double life. They're called oxides, and today we're going to pull back the curtain and reveal what they're really all about. You see them every single day, but I bet you never suspected their dual nature. So let's get right into it. Okay, let's kick things off with something you've definitely seen. Picture a warm summer night and you've got that brilliant, fizzing light of a sparkler. Have you ever, for just a second, stopped to wonder what is actually going on in that dazzling display? Yeah, it looks like straight up magic, right? But nope, it's pure, awesome science. There's a chemical reaction happening right in front of your face. And if we can understand that, we can unlock the whole secret of oxides. All right, so let's break down the science of that sparkle. We're watching something go from a shiny, solid piece of metal to a totally different substance, just a dull powder. And that transformation, that's everything. So here's the deal. A sparkler is basically packed with tiny bits of iron. When you light it, that iron gets super hot and reacts like crazy with the oxygen all around us in the air. That reaction is what creates those incredible sparks. And when it's all over, the shiny iron is gone and you're left with this dull, dark powder. A brand new substance has been born. Now, this fundamental process, an element grabbing onto oxygen, it has a name. It's called oxidation. And believe me, it is happening all around us, all the time, not just in fireworks. Let's dig in. So what is oxidation, really? It's just what it says. It's the process where any substance combines with oxygen. You can kind of think of oxygen as this super social element. It just loves to connect with other elements and form new partnerships. And the results of that partnership? That's what we call an oxide. Super simple, right? It's just some element bonded to oxygen. But don't let that fool you, because this is right where that secret identity we've been talking about starts to show itself. And trust me, you run into these oxides everywhere. Ever seen magnesium burn with that blindingly bright white light? You're watching magnesium oxide being made. The air you're exhaling right now, it's loaded with carbon dioxide. Even the reason your aluminum can doesn't just fall apart is thanks to a super tough, invisible layer of aluminium oxide. They all have that oxygen bond in common. And hey, quick little pro tip here while we're looking at these formulas. See those tiny numbers? They're called subscripts, and they're super important. They just tell you how many atoms of the element right before it are in the mix. So for CO2, that little 2 tells us there are 2 oxygen atoms for every 1 carbon atom. See? Simple. Okay, to really crack the secret identity, we've got to talk about the 2 big families of elements, the metals and the nonmetals. They basically live on opposite sides of the periodic table, and the personalities could not be more different. First up, the metals. You know these guys. Think about a cast iron pan, how solid it feels, how it gets hot so fast, or a shiny copper wire that carries electricity. They're usually strong, you can bend them into shape, and they're great at conducting heat and electricity. These are your classic metal traits. And here you can really see that great divide. Over on the left side of the periodic table, you've got our shiny, conductive metals. And on the right, the nonmetals, which are pretty much their total opposites, often dull, brittle, and terrible conductors. And this big difference, this is the key to everything. All right, this is it, the moment of truth. We're going to run a simple little identity test on our oxides. All it takes is a bit of water and some litmus paper. This is where we finally uncover the secret. So here's the setup. We're going to take a metal oxide, like that white magnesium oxide powder, and dissolve it in water. And we'll do the exact same thing with a nonmetal oxide, like carbon dioxide gas. We're making 2 different solutions. So the big question is, how are they going to act? What do you think will happen when we test them? Let's check the metal oxide first. We test our magnesium oxide solution and boom! The result is a pH that is greater than 7. Now, what does that tell us? Well, a pH above 7 means the solution is alkaline, or what we call a base. The litmus paper proves it, turning a nice shade of blue. And that is the first half of the secret right there. Metal oxides are bases. Okay, now for our nonmetal oxide. We test the carbon dioxide solution and we get the total opposite result, a pH that's less than 7. And yep, a pH below 7 means the solution is acidic, which the litmus paper confirms by turning red. And there it is. That's the other half of the secret. Non-metal oxides are acidic. Two completely opposite identities, and it all just depends on which family the element came from. So let's just boil this all down to one simple, powerful idea. The secret is officially out. Metal oxides behave like bases, and non-metal oxides behave like acids. It's a fundamental rule of chemistry, and it is incredibly useful. Okay, but so what? Why does this matter? Well, knowing this secret isn't just some fun trivia. It actually lets chemists do some really powerful stuff, like creating brand new substances from scratch. You see, when you mix an acid and a base, they do something called neutralization. It's one of the most fundamental reactions there is. The acid and the base basically cancel each other out, and what you're left with is a salt and water. This is where we can really start to create. Let's actually see it in action. Let's say we want to make a salt called copper sulfate. We can use our new secret. We start with an acid, in this case sulfuric acid. To neutralize it, what do we need? A base. And we know that metal oxides are bases, so we can add copper oxide. They react, they neutralize, then the last few steps are just cleaning up. We filter it and evaporate the water to get our final product. And as that solution cools down, what do we get? We get these absolutely beautiful blue crystals of copper sulfate. We took an acid and a base, used their secret identities against each other, and created a totally new substance, a salt. Now that is just cool. So the next time you see rust on a car, you'll know that's iron oxide, a metal oxide. And when you exhale, you're breathing out carbon dioxide, a non-metal oxide. They really are everywhere. So now that you know their secret identity, what other oxides are you going to spot hiding out there in plain sight?